quick. Under normal circumstances, this process should be taking place within milliseconds of the breach to the body. One of the things that will be used is hyperemia. Fluid, rushing fluid to the area, which is what happens with our vasodilation. When those vessels dilate, leukocytes come to the area, we get them moving in, we're going to have macrophage, they're going to get macrophages there, we're going to get natural killer cells, we're going to do everything we can to get our first cells that want to make it to a site to begin attacking anything that has tried to breach it. When the leukocytes arrive, and do you guys remember how I say that we have movement through the capillaries? The term for that in the immune system is diapedesis. You will hear that term again. So movement of the white cells across the capillaries, across the blood vessels, is diapedesis. For the containment and destruction, do you guys remember fibrinogen? What is that? It's the molecule that will help build fibers that will create the clot. So we're going to see that come in because we got to stop the blood, and at the same time that allows platelets to gather, all that sort of stuff to form the clot. Neutrophils are going to recruit macrophages, so they come in, help clean up debris, help fight bacteria, whatever the case might be. If needed, we'll activate T cells and macrophages, and if we need more cells, it'll promote production in the bone marrow. If needed. It's not always needed. The tissue cleanup and repair. Monocytes are a major player here. That actually begins roughly 8 to 12 hours after a breach. Up until that point in time, you're looking at the cells rushing in, the clot being formed, all that sort of stuff happening. So that then mitosis, because that's one of the factors that come along in the blood, okay, mitosis begins to occur. It'll begin to occur for the vessels, it'll begin to occur in the tissue that was torn, whatever the case might be. So that'll actually begin a little bit later after the breach occurs. If needed, cells that came in to help can act as an APC, an antigen presenting cell, which means we need specific response, but only if needed. If it's a situation where containment and destruction has occurred and the cells that rushed in took care of all those little microbes, we do not need help from the specific defense. But if they cannot control the situation, we then need specific defense. Like, for example, somebody cutting their finger and it not healing, getting infected, and they go to the doctor and have to get antibiotics. That would mean our specific defense got called up. But if they cut their finger, healing took place, nothing else was wrong, it stayed non-specific. Does that make sense? Yes, there maybe? Okay. Take a break, be back at 10:30.